Yeah. So what happened in case of the technology? Basically, we move the entire data set to the business logic. Whatever we have implemented, then only our processing will be started. Okay. But in case of our Hadoop, our logic will be moved to the data set wherever it is stored. Then only processing will be start. Writing any MapReduce program or any Hive program or peak program, whatever may be, need to move that particular logic to the data set only. Then only our processing will be start. These things you will be getting to more clarity over this one whenever we are going to practically see some program. Okay, this is the criteria. And moving the data set is really considered, and that's why moving logic is bit easy, right? Lots of memory space will be required. Move the data set to the business logic. And performance will be impacted. Okay. So design to move the computation logic near to the data. It is very, very important. These are all the characteristics. Okay. Okay. HDFS file system. Then HDFS two daemons. There are various daemons are there, but out of which there are two important daemons: name node, master node, name node. Another one is slave node. Okay. Basically, Hadoop distributed file system based on master slave architecture. It means there will be only single master and any number of slave nodes. Okay. Our earlier diagram I have shown you. Okay. I have only one master, but I have multiple slave nodes. Like this. A single master is there, but we have multiple slave nodes. So master node, which are known as the slave node, we can say slave node or data node. Is also slave node, data node. So right now, try to understand here. In HDFS, there are two important daemons. There are other daemons are there. We'll see later. But right now, just concentrate on two daemons. One is master node. Name node we can also say. This is also known as the name node. Okay. Also name. Okay. So the master node, what happened? It is basically maintain and manage the file system data. File system, the file system, not data. We will going to store all the meta information or for each and every file and also manage the files system. Okay, and basically maintains. Let me write down, that will be better. The master, the name node is daemons that runs on master server, also known as master node or name node. Okay, it maintain the file systems. It will store the metadata
Hello. Hello. Your voice is not audible.
Now?
Yeah, right now it's audible.
Okay.
Last
Fine.
5 minutes is not audible.
Okay, sorry, my bad. Okay, master node. The two important daemons are there. One is master daemons, other one is step daemons. Master daemons nothing but the name node, and slave daemon nothing but the data node. So name node is basically runs on top of the master server, and that is nothing. That's why we can say that master node or name node. Master node or name node is responsible to store all the meta information of the data stored in the data node. It will contain like file name, number of files, block name, number of block, and block ID. Also, manage the entire file system by the name node only, because whenever there is a file request is come from the client to the Hadoop cluster, that file will be going to taken care by the yeah. Whenever a file request, okay, it comes from the client to the master node. When a file request is comes to the Hadoop cluster or HDFS, then master node is responsible to take care of this file. As I have told you, each and every file in the Hadoop HDFS system is going to divide into some number of blocks, small blocks, small blocks. That block will be going to store in different nodes. This kind of responsibility is entirely taken care by the master node only. Okay, it's not the because master node only contain which meta information has which block stored in which data node. How many blocks are stored? Okay, what are the different address for that particular block? All these things, all this information will be taken care by the master node or name node only. This name node is only responsible to store the actual data. These are we can show another name also. That's why we'll say also it is a worker node. Worker node also we can say. Here, slave node or data node or worker node only it's responsible to store the actual data, not the metadata. But the metadata for each and every file system data will be stored in master node only. So it is going to gives you the allow. It will going to gives you the permission open the file, write the file, read the file, all kind of access is only given by the master node. Suppose suppose you are for a layman example, you are a principal. Okay, you are principal of one college. You are head of the department of one department. Let's say computer science. So based upon your instruction only, staff will going to the class. Okay. Suppose you are a team leader. Let's say in organization that will be better. You are working in a team in a particular project. Who will going to give you all the access? You need to raise for each and every access for a separate request, right? There is an authority, admin, and they are going to give you the access. So master node is nothing but the authority. Whenever you are going to send the file, that file will be always accepted by the master node only. Without the permission of master node, you cannot do anything. Master node only gives you the permission to access the file once it is stored in the HDFS file system. Then you can allow. Then he will going to give the permission to open the file, push the file, read the file, write the file. One more thing, it's based upon Pura concept. That means write once, read many times, any number of times. Okay. We can write the file only once to the HDFS, but we can read as many times we require. Okay. Same file will be read as many times we require. So these are the important characteristics of HDFS. It's designed to run on a hardware commodity. It's for storing huge files, huge in size, not for small files. It's fault tolerant. Fault tolerant means backup mechanism is so good that we can at any point of time hardware fail will occur and we can address such kind of issue and come out of the failure. We can able to process our we can perform our processing synchronously without any failure. High throughput means it is able to scan millions and millions of records within fraction of second and process it. The low latency means it will take less time to complete a particular task. Okay, HDFS daemons. Two daemons, one is master daemons, another one is slave daemon. Master daemon is responsible to store only the meta information, manage the file system data along with the different kind of permission. It will allow to control access like allow us to open, coach, read, and write access to system data. Okay. Data node is only responsible to manage the data. Okay. So all these points we get lots of clarity whenever we are going to deal with the block size. Okay. Next topic is our HDFS block storage. These things we will discuss in the next session. But anyway, this node is not complete. Anyway, I'm going to show you one node, the completed node.
Now, what is the meaning write once, read most?
Write once means at the time of whenever a new file comes,
Okay.
That file will be going to stored in HDFS file path. That is a one time only. That is called write option. Read means that once that file will be stored, then only we can process, right? Suppose in your computer system, the file is there in your pen drive, you cannot read that file. Either you need to read that file, you need to inject into your USB port, and then only you can able to read. Else you need to bring a do copy of that one into your local system, and then only you can read that. Okay. Suppose this file system. This is a file system. Okay. This file is already. Suppose let me. I have given you. You have make a copy of this one and store in your system. You can read as many times you require. Okay, in your HDFS file system, once this data will be stored, you can at any point of time you can use this files and do your operation on top of these files. In case of Oracle database, what happened? The data will be stored in the form of rows and column, and using that particular data, you can going to do your operation. In case of we are going to perform our operation on top of file.
Okay.
Okay. Getting my point. This file I can read as many times as required. So you will get you will understand slowly because this concept few things are new to you. So once we'll go for practical, lots of clarity you will get. Today once you'll go through the block storage system in HDFS, that point of time you will come to know. Okay. Just go through this note I will share with you. It is not yet completed. Which block storage? What are the different kind of blocks we can how when we our HDFS get a file, how it is going to divide the entire file into number of small blocks and going to store in a HDFS file system that we are going to see. At that point of time, we can able to understand the fault tolerant more clearly. Okay. No, this is a rough note I have given, but I need to modify a few things here. Okay. Here it is clear. HDFS is a distributed file system designed to store large volume of data to run on a cluster commodity hardware. It is highly fault tolerant and designed to deploy in a low-cost software. HDFS provide high throughput access. High throughput access means at a time I can process huge amount of data. Okay. It is suitable for application that has large data set. Large data set means the size of the data file is large, not small data files. So this point also we are going to see in our block storage. How it will happen. HDFS is designed to store large files. HDFS is highly fault tolerant. HDFS is high throughput. HDFS is designed to run on a commodity hardware. HDFS is designed to move the computation or business logic near to the data that is stored. HDFS has designed to be easily portable from one platform to another platform. This is another point. Okay. That means we can install our Hadoop in any kind of operating system that is supposed to be supported by the Java. We can install our Hadoop on top of CentOS, Ubuntu, Fedora, Windows, and macOS, and so on. Okay, that's why it's portable in nature. Platform means operating system. Platform generally refers to the operating system. In any operating system, you can install your Hadoop. Hadoop is installed, that means two important daemons will come into picture automatically. One is your HDFS, another one is your app radius. Okay. This is Hadoop nodes. What are the HDFS nodes? One is master node. You see here. One is master node, another one is slave node. Okay. HDFS is based on the master slave architecture. Means it has only one master that runs on the master server and any number of nodes, slave nodes. Whereas master node is known as the name node, slaves are known as the data node. HDFS master. This daemon runs on a master server and regulates the file access to the client. Maintain the namespace, metadata, like maintains the slave nodes file's name, number of files, number of block, storage location of block, block ID, replication details, and so on. Okay. Also, find the it will be opening, closing, renaming files and directories. Okay. Slave nodes. There are n number of slave nodes. There is no limitation. Hadoop distributed file system can add as many number of slave nodes required when add. Okay. These are all the important points you need to go through. I have noted all the important points clearly. We will go for the HDFS storage system, block storage, and this is very, very important. Whatever we have studied so far, as compared to this one, it is very, very important. If you understand this point, HDFS block storage, you are able to understand the whole HDFS concept. Okay. We are going to see HDFS block storage and also replication. HDFS block replication. This is another one. Okay. Any doubt so far?
No.
Yeah. Let's stop our session.
Yeah.
Only. Okay, I will upload all these things in shared drive so that you can download and visit to the session. Okay. So I will going to share the notes, all this. Okay.
Yeah, thank you.